Well, hi, and welcome to the Graph+AI Summit. My name is Jeff Pullman, and I'm with Mastech Infotrellis. And joining me today is Deepti Soni. She's the head of our data science business unit, and I'm the head of the data engineering unit. So what we're going to talk about today is connected business intelligence. It's a form of next generation master data management, in so much as what we'll chat about today is how the importance of what TigerGraph technologies bring to the table relative to linking key operational aspects of your business together, and what kind of value that will provide your organization. So the agenda today, we're going to talk about what it is. We're going to begin with the end in mind. We're going to go through a use case that revolves around food traceability. Then we're going to chat a little bit about how do you get started if you wanted to take the first step toward developing a solution leveraging TigerGraph, and how you specifically work with organizations in order to drive the value out of it. So it's clear that the effort is not wasted, and that the amount of value that you drive out, that you pull out of your solution, is something that is going to be everlasting and future-proofs your organization. So what is connected business intelligence? I think we've all talked about BI and what BI is, and tend to think of it as reporting, or a reporting framework, or a platform. What the context of business intelligence is, in reference to what we're speaking today, is more about the intelligence of an organization rather than merely just the reporting aspects of the group. So what I wanted to talk about is how this digitally transforms an organization. The amount of service, it's just an uplift in your ability to provide service to an organization. It's accretive levels of intelligence as you build out, because we all know that when leveraging graph technologies, in particular TigerGraph, it's a very agile solution, in so much as that it learns as new data is introduced into the solution. It's going to be an augment to your legacy systems, not rip and replace. This is not something that is going to replace existing legacy systems within the enterprise. And we want to be able to deliver this with some level of modularity, so that it's not a big red easy button. It's not a great big unencumbered project. This is something we want to be able to be a piece at a time as it makes sense for the organization, so that it provides that measurable ROI on a rolling basis. So as each new module is built, is released and comes into production, that the value of it is easily detected, and that it can be self-funding, if you will. And lastly, this is an intelligence service for your intelligent consumers and intelligent delivery. So this is making that digital connection to the existential consumers of your product or service, as it might be. But today we're going to talk through the use case of food traceability, and Deepti will go into that more in a moment. At Mastech, we think about a data landscape really and design it around 5 tenets, right? So data must be free, in terms of that it must be able to extract it out of the systems that it resides in. So that's what we interpret when we say freedom. It must be free to be able to be pulled out. It must be connected. It must be directly proportional to its connection nodes. So the data must be able to be linked to other pieces of the enterprise when we're working with it. It must be analyzed at scale and operated one-to-one. And when I think about analyzing and designing, you need to be able to look at this in terms of terabytes and not in terms of gigabytes, because it's going to be deployed to where you're looking at hyper individuality. As the nature of graph technologies, with the focus of our organization, whether it be food or whether it be persons or customers, it's going to be very much scaled to focus on them. The 4th tenet, it needs to be in the cloud. The whole reason we can do these wonderful things is the agility that the cloud provides us, in so much as that we have virtually unrestrained compute power, unrestrained storage power, and storage capability, and the ability to leverage that on an as-needed basis. It's changed the paradigm with which we can think about solutions, how we imagine the future of our organizations. This is really about transforming the intellect of a business. Now, when you think of an ecosystem of information that an organization as it exists today, there's a lot of information that exists within the walls of an enterprise or in the confines of that. Much of it is not used. I think that there's a statistic that says roughly 30% of the data that an organization collects is actually used. Probably even less of that is analyzed. So when you think about an intelligence transformation, what do we want to do with that? And how do we want to impact the organization and its capabilities? When you think of bringing TigerGraph into the fold, what do I want to do? Well, I want to look at the focus of my business, but then be able to reach out and touch the other pieces of data that exist within my ecosystem to pull that into the sphere of intelligence within the organization. So that means that the TigerGraph solution is at the central focus, providing, if you will, the brains of an organization so that it can then be able to expand its knowledge about individuals, about assets, about products, about services, so that we provide our customers and the consumers of our services with the absolute best service or quality of product possible. So when you think of what kind of things it does from a customer service perspective, this facilitates self-service, entity resolution. How do I think about augmented reality and how I interact with my customer? It ups the level of communication in terms of specificity and value, and then it gives us the ability to hyper-personalize our messaging. One of the biggest things one of the areas that organizations struggle with most is what's the right message at the right time with our customer. And being able to understand that on a very personal level is going to make the difference between a sale and a new sale. So I want to turn it over to my colleague Deepti, and she is going to discuss the use case that we've brought in today around food traceability.
Thanks, Jeff. So as Jeff described the value of connected business intelligence, I would be dwelling down into its applicability into food traceability use case and would like to discuss some of the implementation aspects at high level. So to define basically food traceability in a food supply chain is all about ability to track and trace a product across the supply chain throughout the product life cycle. So it means tracking the products and its ingredients from, say, farm to retailer to consumer when it moves across supply, manufacturing, distribution centers at each stage of the supply chain unit. So with the current market and the current compliance requirements, it's just more than just a nice to have thing. Let's go to the next slide, please, Jeff. Thank you. So this is basically highlighting some of the statistics involved around why traceability matters. It also improves in suppliers matrix in a way that it helps. It helps to improve communication and data and information exchange between all the parties across the supply chain, in turn improving the accuracies of predictive analytics. We have more accurate data, we have more fresh data, we can plan risk mitigations more accurately with the latest information. This overall works to improve brand perception and customer loyalty, which both are very important for a company growth. Food wastage is also one of the very prime concern for governments as well as consumers today. So in United States itself, food waste is estimated at 31% of the food supply. So basically, with this kind of a visibility, we are able to trace back where the problem occurred, where the food got spoiled as a part of a supply chain, and we don't have to, withdraw or during the event of food recall, we don't have to withdraw on all of the items that was part of that supply chain as a delivery. However, we can only withdraw the affected food items, so thus reducing the amount of food waste. This, how traceability helps, basically it enables more effective identification of possible vulnerabilities in the supply chain. For example, determining and measuring food loss occurring at inspections or in transit. So at each handshake, we are having more detailed data, and thus we are able to track the right spot and take an appropriate action. In the end, I would like to conclude it like it definitely improves the customer trust. Not just in terms of that with respect to food allergies, it is easy for us to track those allergens which are part of that product, track that complex product ingredient relationship. All these kind of information providing to the customer enhance credibility to the story, that is like farm to fork story. So what exactly is what we are eating in our fork is related to all possible small ingredients, which further establish our branding, and it improves trust in product provenance and secure customer confidence for quality, societal and environmental impacts. As today's customer and consumer is like very aware, is health conscious, and is moving towards environment consciousness as well. So all these right information on the label helps in mitigating and reducing these impacts. So in all, basically, it's just not the sum of the matrix or other thing that improves. It's more than that, the data only. Next slide, please. So I would like to discuss a solution around food traceability at high level. So as shown here, this is a high level knowledge graph. In any supply chain, data, or maybe we can say information, flows from raw material source to supplier, retailer, manufacturer, then it goes to distribution center, and then to a retailer, and ultimately to a consumer. So as to implement this use case, we have to first design an ontology implementing food traceability in the supply chain. The ontology should be designed in a way to add meaning to the data. When a graph is created, there should be meaning to every data point, and that meaning and context comes from the linkages that is there in the domain, and we should be able to absorb those linkages in our ontology. Good ontology does provide more than just data. It provides context to data. It supports the faster access and enable us to leverage the power of inferences that we can get from those linkages, and the power of reasonings. After creation of an ontology, the next step is basically to ingest data into it to create a knowledge graph. So data in this supply chain basically spans a wide spectrum of in terms of data types, in terms of tools and technologies used. Say, for example, it may be coming from structured systems, ERP systems, some demand data, sales data, inventory data. It can be location data. We can have barcodes, sense RFID sensors data. We can have cameras. We can have internet, social networking data. So it spans a wide spectrum. And it needs to be, it is a mix of structured, unstructured information, imaging, and a lot more. So we implemented our knowledge graph in TigerGraph to integrate this heterogeneous data across the supply chain in a meaningful way. As a process of ingestion, we use several machine learning NLP-based techniques to draw meaningful, information from that raw data. So basically, at the end of the day, it is including ingesting your streaming data coming from factories, warehouses, distribution centers across industries. So in terms of tech stack, TigerGraph supports most of the variety of ETL tools. We have used Kafka and string sets to ingest data, and it is deployed in TigerGraph. TigerGraph supports faster processing, and it loaded the large amount of data in a relative less time. So this graph basically shows some of the key data elements shared across each handshake and how product moves in a chain. For example, when we have raw material, there can be some information about crop information or about the farm, geolocation of that farm. There can be weather conditions, fertilizers used, machinery involved. And when it is sent to supplier, more information is appended to it. So at each transition, we have more key data elements added. Each transition has handshake information, and all this is very different. It involves different parties as well as different types of data, and therefore requires a systematic ingestion process, and requires a lot of harmonization and standardization of the data. So that is a one key concept that I would like to emphasize again, that when implementing such a use case, we have to address needs of data harmonization, and data is ingested at various velocities. It has and veracities. So these are difficult and less performant in with the traditional relational platforms. So after this iteration, after designing ontologies, after pre-processing and adding data and creating a knowledge graph, we have a knowledge graph that supports faster and uh, multi-hop traversals are very easy, and linkages provide additional context. So it enables business to get real-time visibility and control the entire data, which can be internal to the system, internal to a unit, and I mean, what they gathered across the network of partners across the supply chain. Uh, as a result, this knowledge graph will be basically providing a single source of truth across the entire supply chain. So that in turns create a digital history of a product and which can be accessed by each of the partners. We can have all scope and access controls as needed, as defined by the system, uh, enabling visibility and better operational efficiencies. So as a next step, after ontology and data ingestion, creation of knowledge graph, we can apply graph analytics algorithms into it and our machine learning based approaches to read data out of the graph, compute, perform predictive analytics, or any other such descriptive analytics, anything that we need to with respect to supply chain optimization, with respect to retail forecasting, inventory management, or many more use cases. Particularly if I name a few, like how graph value adds there. Basically, graph-based analysis is, we can perform a pattern analysis that allows data to be analyzed, not just as a single unit of a data, but as a full pattern, and thus providing more information in less time. We can since our graph allowed to link, and now we can access that complex product ingredient combinations in a very easy way. Graph-based pathfinding algorithms can help us identify alternative manufacturing sources based, for example, in case of food recalls incidents, or in case of any unforeseen incidents, we can find the optimized route, we can find the alternate routes. These problems are basically graph inherent. So graph algorithms perform really well when the data is structured in a graph. Then the basic link analysis exploration also allows searching for each product affected by specific raw material or specific use cases. So like in the previous slide, we mentioned that we can reduce the amount of food wastage. So that link analysis can can help us to identify the exact lot or batch to be discarded instead of discarding the whole more bigger size. Overall, creating a supply chain transparency for all products, and this is in partnership with manufacturer for faster, effective access to each part of the supply chain. Next slide, please. So this slide basically is listing how food traceability in knowledge graph is particularly useful. So I covered a few before, and I'll touch upon the main points here. For example, product identification. So it provides, the way we connect data in graph, it provides visibility and single source of truth across the supply chain. And any stakeholder who is reviewing that, who is using that supply chain, is now aligned and using the same data and same information across the supply chain, which makes interoperability easier, faster. And link management, it supports identification and traceability from, say, like I said, from raw form to the fork. So that ways we can connect all third-party data also to it, and we can capture information flow along with the physical flow. We can include master data about the product, transaction data, information about movement, and like I said, third-party data, quality certifications, which may be reports, and we can use NLPs to get useful data out of those reports and include with the product or a raw ingredient wherever it is rightly suited. So we can, whenever we are tracing back, we have that information at our fingertips and we can take appropriate decisions. Then we in food traceability, there's a CTKD framework that is basically regular. I mean, that is defined for compliance purposes. So linking data this way helps in harmonizing that framework so that all parties which are part of it are talking about same CTE and same KDE, and they are, I mean, there's a lot of mismatch because there is a guidelines, but that still needs to be harmonized. So graphs are flexible and they help to standardize it across their all supply chain partners and integration of third-party data. So this basically allows our graph to keep up with the compliance changes faster. Then we have semantic discovery of data, which is basically, it helps businesses to automatically derive meaning of the data. In simpler words, basically, it enables us not to just find only keywords, but find the intent or context of the words. So this makes our searches faster, more realistic, more business oriented. It recognizes multiple references of the same entity and can provide additional information related to the query. So overall, it improves the customer trust. So food traceability on a graph it is an inherent graph problem because it is all about linkages, connectivity, and that traversals, which traditional relation system, because we are avoiding the multiple joins and combining unstructured information. So graphs are very suitable for this use case. And lastly, next slide, please. We can basically combine our, say, TigerGraph based knowledge graph with any of the BI tools, Power BI, Tableau, and then we can generate insights. This is a sample dashboard in which we are just plotting how that supply chain, the major events of the supply chain, that if disruption or container shortage event happened, COVID spread, how it influenced. We can drill down into the report and see what all was the influence. For example, possible delays and disruptions by sector. So in 2021, transportation was impacted. In 22, distribution center had some impacts for this data. And we also can track down the food recall events and take appropriate actions. So this kind of a dashboard for insights is we can easily create of the TigerGraph based solutions. So that is pretty much it about the food traceability that I would like to cover today. Thanks, Jeff. Over to you.
Thanks, Deepti. One of the things that we always speak with our customers about when they embark upon a graph solution or graph project is like, how do we get started? It's somewhat of a nascent technology from a commercial standpoint, although graph databases have been around for decades. The tools and the capabilities that TigerGraph brings to the table have enabled many organizations to take that first step. And it has simplified the process to a certain degree, but there's still a level of effort that's required in order to be able to get this right. We've developed somewhat of a framework in order to work with our customers that includes collaborating jointly between their teams, their internal teams, and our internal teams as consultants. And then basically to go through the process of ideating, prototyping, impact, and then measuring the impact. So as with any project, as I mentioned earlier, that you really want to be able to capture what is that outcome, and more importantly, what is that improvement? So this is a cycle. This is not a one-off. As you go through the sprint cycles of an engagement, each cycle will include these steps with the expectation that out of that will come, the ability to move forward with your project. And one of the things that I think that, particularly with a graph solution, is that this is very use case driven. In so much as that, it's not something that's all encompassing. You don't boil the ocean to see what problems pop up. You look to see what are those really, really valuable problems that can be solved by deploying a graph solution. So how do we approach that in order to tease that out is, some of the initial ways to start is like do an inventory of the system, find out what what sources of data exist within the ecosystem, whether they be ERP, whether they be data warehouses, whether they be third party, whether they be unstructured or semi-structured information that exists in storage, and how does that impact the problem that you're trying to solve? How does it relate to the problem that it solves? But the most important step in the next part of the journey is developing that ontology. And Deepti talked about that. And that is really it is a team sport. It is not an individual effort, that it requires all hands relative to being able to get involved and understand what the business problems are surrounding that particular use case, because that's the only way that you can tease out that value. And then, of course, the model development and build those initial data pipes so that you can have that MVP up and running very quickly and demonstrating the value that TigerGraph will bring to the organization and enhancing semantically their ecosystem. So if anyone has questions and answers, we'd happy to take those at this time. Thank you for listening. We appreciate it. Us here at MassTech InfoTrellis, this is an exciting time to be doing what we're doing in the data and analytics space. And thank you very much.